this should be a pretty quick video. I'm just going to show you how you can use the fundamental theorem of calculus to solve these kinds of problems where I'm just repeating the one I did that we approximated using rectangles, but now we're going to do it using the fundamental theorem of calculus. So if you have a marginal profit, cost, or revenue, whichever, given to you, a function, and you want to determine the total function, for example, for the first year, the profit for the first year would be the definite integral. Now I'm not writing rectangles, but or doing the triangles, but I'm actually going to do it with the fundamental theorem of calculus, and saying it would be the definite integral between 0 and 12 for the first year. Remember, the t is given in months, so to the first year you go from the month 0 to month 12, and then you have your function is 0.2t and then dt, and you calculate that. Remember, you need an antiderivative of this function right here, and that would be 0.2 times t squared over 2, which you can write just as 0.1 t squared. So this would have been 0.2, then t squared over 2, so divide the 2 with the 0.2, divide the 0.2 by 2 and get 0.1, and you're going to evaluate it between 0 and 12. So when you evaluate it at 12, you get 0.1 times 12 squared minus, you evaluate it at 0, 0.1 times 0 squared, which is 0. So you get 0.1 times 144, which is 14.4, and this one, remember, was in thousands of dollars. So this is the same answer we got last time, just the only difference is now we calculated it using the fundamental theorem of calculus. So for the second year, you would do the same, except now you go from the month 12 to the month 24. And then you get the same function, 0.2t. So you do the same thing we did before. You calculate an antiderivative and go from 12 to 24. And then you get 0.1 times 24 squared minus 0.1, and you evaluate it now at 12, so 12 squared. So you evaluate it at 24 first, and then subtract the function evaluated at I want to just go a little, oh well, I guess I won't be able to fit everything on the screen. Okay, so now we just evaluate it, and what do we get? So we get 43.2 thousands of dollars. So this is how you would solve these problems.